I always write the date. I think it starts to write the date, so I write the date.
Well, I write the date just so, like, if you look at the video or something, you can see what date we actually did this on. So, okay, particle motion. So here we go with physics again, right? Physics keeps kind of dabbling itself in here. We are still talking about position, velocity, and acceleration. So we've already been through the connections there, right? You've got position, velocity is the derivative of position. Right. And then acceleration is the derivative of velocity or the second derivative of position. And of course, reverse those for integrals. So let's look at example 1. A particle moves along the x-axis according to the acceleration function a of t equals 3t. The velocity when t equals 0 is negative 10, and the position when t equals 0 is 6. Find the equation that describes the position of the object as a function of time, and what is the position when t equals 2. Okay, that's me doing all the reading. And of course, you reread it about a bazillion times or whatever it takes to make it make sense, right? Okay, so we have... Well, I know when it's me reading it on my own, I have to break it down, and I reread it several times before I'm content with what they're giving me. So they give me an acceleration function. The velocity when t equals 0 is negative 10. The position when t equals 0 is 6. And we want to find the equation that describes the position. And then we'll talk about position when time equals 2. Okay, guys. Well, we were given the fact that acceleration is 3t. If we're trying to work our way to position, what do we have to think here? Okay, so we're going to talk, I guess I'll do that. The integral of acceleration is equal to velocity, right? So I'm going to say that velocity is the integral of a of t, and technically that would be a of t dt. Oh, why did I just put a of t in there? I should have just gone ahead and put 3t. I don't know why. Which, realize, that's the same thing, right? Oh, one too far. Oh, well. We got it. The acceleration, or velocity, is the integral of acceleration. What is the integral of 3t? What was it? Okay. 3 halves t squared. Technically, we're going to say plus c, right? So we added 1 to the power, divided by a new power, so 3 halves t squared plus c. However, do we get to leave that plus c today?
No, because we know that v of 0 is equal to negative 10.
Right. We were given velocity when time of 0 is negative 10. So we were essentially given v of 0 is negative 10. And so if you plug this in, v of 0, so 3 halves times 0 squared plus c, and what's that have to equal? That's officially what you're doing, right? And I do that because do they always give you when time is 0? No. Now realize when they give us when time is 0, basically they're just telling us right there that they're telling you what c is. So c is negative 10. So my velocity function is 3 halves t squared minus 10. Are we okay with the velocity function there? Okay. We're trying to work ourselves to position, which in a position situation like this, I tend to say x of t Depends, sometimes it's x of t, sometimes it's s of t. But, so x of t. How are we going to find the position function? Okay, we're going to integrate velocity, so we're going to integrate 3/2 t squared minus 10. And of course that is dt. Integral of 3/2 t squared.
1/2 t.
Okay, add 1 to the power, becomes t to the third. Divide by that 3, and that 3 will cancel. So 1/2 is still there, t to the third, minus 10t plus c. But
C is 6.
the short of it is c is 6, because we are told the position at time 0 is 6. So x of 0 is 6. So if I do the official math, 1/2 times 0 cubed minus 10 times 0 plus c is equal to 6. So c is 6. And our position function, x of t, is 1/2 t cubed minus 10t plus 6. So what were we being asked to do? Find the equation that describes the position of the object as a function of time. Check. What is the position when t equals 2? How do I find the position when t equals 2? Yeah, we're going to plug in the 2. So x of 2 is 1/2 times 2 to the third minus 10 times 2 plus 6. 4 minus 20 plus 6, negative 10.
And we do meters because it didn't give us anything. Or units.
Units. When it doesn't give you anything, it is just a generic units if you need a label. What does a negative 10 mean in terms of position?
We move 10 in the negative direction.
Yeah, 10 to the left of the origin, right? Or 10 to the left of 0. So just so you realize, when they talk about that negative 10, that is 10 to the left of the origin. Okay, so just understand what that means. First problem, okay? I like that one, right?
Yeah, we've pretty much done it before.
Yeah, you've done those pieces, those types of pieces before. So, and that's, I feel like a lot of what we're doing today, we've done to an extent before. I don't feel like it's, So, okay, moving along then. Example 2. A particle moves along the x-axis such that the acceleration function is a of t equals negative 3t. Its position when t equals 3 is 20. Its velocity, t equals 1, is 5. What is position when t is 4? Also, at what times is the particle changing directions? Get that all? Let's see. This time, acceleration is negative 3t. Position when t equals 3 is 20. Velocity when t equals 1 is 5. What is the position when t equals 4? And at what times is the particle changing direction? Those are kind of the pieces we have to find there. Well, you know where we're starting, yes? And I have I don't know. This one takes up more space for me, so. A of t equals negative 3t is our starting. That's what we're provided, yes? So what do we find once from the acceleration? Yep. We're going to find the integral of acceleration, and that's going to provide us with velocity. What is the integral of negative 3t? Similar to the last one, except this time it's negative 3/2 t squared. Add 1 to the power, divide by that new power. What's different this time? Yeah, t is not 0, is it? You have to be careful. Don't just jump in and, okay, well, I know my c is 25, whatever. 5 in this case, I guess. You know, you can't just jump in. We know that the velocity when t equals 1 is 5. So v of 1, when you plug that 1 in, so negative 3/2 times 1 squared plus c, that equation is 5. And that's why I show you the method, because time is not always 0. Do the math. Negative 3/2 times 1 squared. It's going to be negative 3/2 plus c equals 5. We're trying to solve for c. I'm going to add the 3/2 over. At least that's what I would do. And 5 plus 3/2 is, okay. My brain was going 6.5. My brain just hadn't made it that far yet, so I agree. It is 6.5, but realize 13/2 is going to be the more appropriate way to express your answer within an equation. So what is my velocity equation? It's negative 3/2 t squared plus 13/2. It's my velocity equation, right? So now what?
Well, it wants to know the position when t is equal to 40. So yeah,
Okay. It wants no position, so we're not stopping yet. So in order to find position, we're going to integrate velocity. So we're integrating negative 3/2 t squared plus 13/2 dt. Let's see. Integral of negative 3/2 t squared. Add 1 to the power, it becomes 3. Divide by 3. Negative 1/2 t to the third. Integral of 13/2 is 13/2 t plus c. And c is not just 20, is it? Okay, we're past that easy step. So position when t equals 3 is 20. So I know x of 3 is 20. So negative 1/2 times 3 cubed plus 13/2 times 3 plus c, and that's going to equal 20. I like the last one better. Just saying. I'm just saying what you guys are thinking, right? The math worked out a little bit better on the last one, so.
at least this one cleans up nicely if I did it right.
Okay, well, 3 cubed is 27. Negative 1/2 times 27, I'm going to say negative 27/2. 13/2 times 3, 39/2. Plus c equals 20. And must be where Ross is saying it cleans up nicely. Negative 27 halves plus 39 halves is going to be 12 halves, right? Which is 6. I do like that. 6 plus C equals 20. And so C is 14, if I've done my math correctly. Hey, my notes agree with me. That's always good. So, position function. X of t is negative 3 halves. Nope. I was trying to do a velocity position combo deal. It's supposed to be negative 1/2 t cubed plus 13 halves t plus 14. Now did I get it right? Too many things going on. And I'm even trying to be organized. I really am. There's just a lot going on. Okay. Well, what are you finding first? Position when t is 4. So we're finding x of 4, if I'm not mistaken. So negative 1/2 times 4 cubed plus 13 halves times 4 plus 14. Okay. 4 cubed is 64. Negative 1/2 times 64 is negative 32. 13 halves times 4 becomes 13 times 2, so 26 plus 14. Negative 32 plus 26. Negative 6 plus 14, 8. So x of 4 is 8. If you want to put a label on there, that is 8 units. And what kind of position is a positive 8 units? That'd be 8 to the right of center of 0 or 8 to the right of the origin. Okay. So 8 units right of the origin. We had something else to find too, didn't we? Also, at what time is the particle changing direction? Okay, so when does something change direction? When that velocity goes to 0. Okay, that is when, so we are trying to figure out when does velocity equal 0. So what was my velocity equation? Negative 3 halves t squared plus 13 halves, set it equal to, 0. So I'm going to subtract the 13 halves over. Negative 3 halves t squared equals negative 13 halves. I personally am going to multiply by the reciprocal. So if I multiply by negative 2/3, negative times negative becomes positive, 2's cancel, and I end up with 13/3. Pretty sure this is how it's supposed to work out, yeah. And so what is t? If t squared is 13/3, then t is the square root of 13/3. to leave it. Okay, they did leave it as just square root of 13/3, which is kind of what I thought they'd done. I don't remember exactly. Okay. Now, this is the other reason I had to check the book, because I always forget what their reasoning is here. Notice, when you take the square root of an equation, officially what do we do when we take the square root in the equation setting? Plus or minus. Now, the question I usually get is, this is time. Do we really need the plus or minus? And they actually have it in here, which is what I was just looking back on. Let's see. Of course, we checked both values make sense to this question. Looking back, no restrictions were given on the domain of the acceleration function. Okay. This means that negative values of time are perfectly acceptable. They simply refer to times before some particular reference point in time called 0. Therefore, the particle changes direction at both the negative and the positive. Okay? So that's why I was double checking before I finish that off. So it gets a little tricky about the pluses and the minuses. Okay? That wasn't horrible, was it?
The next one's not looking too good.
You don't like the next one?
You would be falling his eyes out right now.
What?
He will be in the corner.
Yeah.
Well,
Great.
Who would?
I said my algebra 2 me would be.
Oh, okay.
I saw that.
Okay, well. But your calculus U is much more matured, so your calculus U will be fine with this.
We'll see.
Give it a chance. Okay, a particle moves along the x-axis, so that its velocity at time t is given by v of t equals 1 over t for t greater than 0. So notice they are restricting t to be greater than 0, positive. And its position is 5 when t equals 2. Find the time when particle is 10 units to the right of the origin. Okay, so they give me a velocity function, right? V of t is 1 over t. And for good reason, they defined t has to be positive. Its position is 5 when t equals 2. Find the time when the particle is 10 units, and notice it's to the right of the origin. Okay.
So position is t plus c.
Because position is going to be the integral of velocity. So v of t is 1 over t. And if that's the case, then we know the position. So x of t is indeed the integral of velocity. So it is indeed the integral of 1 over t dt. That's one of those special cases, isn't it? It's best if you can recognize the integral of 1 over t. And so the integral of 1 over t is the natural log of t plus c. Now, I'm really trying really hard to ignore the hallway. It's just difficult right
I thought
now.
it was an actual goat blonde. I was like,
The thing is, it wasn't an actual goat.
but
That's the
it
thing.
sounded like one.
It was one of our human students,
Didn't Garrett Freeze go into school that one time?
as opposed to one of our animal students. Is that what you're trying to get me to say here? I don't know. Okay.
That wasn't very inclusive, Mrs. Sargent.
Okay. Word of comment here. If you forget that this is a special case of natural log of t, I think I've said this before, but if I try and integrate, it's t to the negative 1, yes? When I add 1 to that power, negative 1 plus 1 becomes 0. And you're not going to have an integral of something be t to the 0. So that's kind of the red flag that goes off in my mind. Oh, that's supposed to be natural log of t. Okay? Now, we were given a restriction, yes? Or a, not restriction, a statement. Position is 5 when t is 2. So we were just told that x of 2 is equal to 5. So the natural log of 2 plus c is going to be equal to 5. So c is a lovely value here of 5 minus the natural log of 2, and we are leaving c just like that. It's fine. You may not think it's fine, but I promise it is. So my position function, x of t, is the natural log of t plus 5 minus the natural log of 2. My constant is in 2 pieces, but we'd rather have an exact constant than an approximate constant. You don't want to round and give me a decimal. Okay. Find the time when the particle is 10 units to the right of the origin. So what am I doing here?
So x of t has to equal 10.
Okay, so we're trying to set x of t equal to 10. So natural log of t plus 5 minus natural log of 2 has to equal 10. Want to get that variable by itself? So we're going to start by getting natural log of t by itself. I already have 10. If I subtract the 5 over, that puts me at 5. If I add natural log of 2 over, are we okay with 5 plus natural log of 2? Okay, where's the algebra 2, Ethan, at?
So, yeah.
Need these algebra 2 steps here, guys. There's an invisible e there, isn't there? Natural log is base e, so there's an invisible e. And so you can indeed think left, right, middle. So e to the 5 plus natural log of 2 is equal to t. Need your reminder of left, right, middle. There you go. So let's see. If I reverse that, e to the 5 plus ln of 2. And this is where, I mean, if it's a non-calculated problem, you're obviously done. Okay, I do have a decimal answer in my notes because you can plug this into a calculator, can't you? So it kind of all depends on the problem. E to the 5 plus ln of 2. I have 296.8263. You can double check that, but this wasn't a horrible problem.
I'll give up.
It's not a horrible lesson.
No.
Oh, definitely not a horrible lesson. I actually, this is one of those lessons that, I don't know if I was gone or whatever last year this time. I forget, there was something in my plan book, but this is a lesson that was done via video last year. So.
Hospitality.
Yeah, that's why I just let that to the hospital.
Okay. Pronounce it right, guys. It's L'Hopital.
So,
Okay, 4 and 5 in tonight's homework probably come from lesson 77 that we just skipped, yes? And so they're going to be replaced with 21, 22 from 77.